Welcome to the webinar Creo Simulation Live 7.0. My name is Urs Simler. I'd like to talk a little bit about new capabilities in Creo Simulation Live in the old versions 4, 5 and 6. And I'd like to talk about new products in Creo 7.0 which came out on Tuesday. First, this is my agenda. Talk about me, the company I'm working for, GIA Informatic, and then we'll see the enhancements of Creo Simulation Live in the old versions 4, 5 and 6. Then we'll see some new information about the solver. Ansys is updating it. We'll have better performance, and then we'll see the news in Creo 7.0. And we'll see the new product in Creo 7.0 called Creo Simulation Live Fluids. The most of the time we'll spend within demonstration, so I will do, let's say, structural, thermal and modal demonstration on a motor block. This capability is available in Creo 4, 5 and 6. And then I will do quite a lot of models, 3 models with Creo Simulation Live Fluids. This product is only available in Creo 7.0. Okay, and as I told you, at the end we have a Q&A session, and therefore please use the question panel. Great, who is speaking? This is me, Urs Simler. Let's say my name states for me or for the things I'm doing. I would say, simulation expert. I know a little bit CAD system, Creo Parametric, and yes, I like to work with the simulation tools in the CAD environment. I guess our salesperson, Daniel Loth, is also in the call. If you have any question about pricing and that kind of stuff, you can contact him directly. By the way, I'm also an owner of a YouTube channel. This is the YouTube channel. Feel free to subscribe. There is enough space for your subscription. Who is GIA Informatic? GIA Informatic is located in Switzerland. We are about 140 people. We belong to the Müller-Martini Group, and we sell SAP solutions. We have 3 own data center, and we have a team for the CAD CAM PLM stuff. And we'd like to support our customers, our successful customers. And in the CAD PLM environment, our main partner is PTC. And beside the PTC products, we're also selling, supporting other products from partners, PTC partners in the CAD PLM environment. So we offer sales and training for PTC Creo Parametric, including all the simulation tools, Creo Elements Direct, the older co-creator products, Windchill, MatCAD and so on. And from partners like CAESS, we have additional products for topology optimization. From Elaborate, the German company from Nuremberg, electrical clearance and creepage analysis. And we also support solutions from TechSoft, Software Factory, and B and W software. We are monitoring PDM systems from our customers. We have an own training center, and I think we're quite experienced. Then let's have a look at the Creo Simulation Live news. These enhancements, these enhancements are available in Creo 4, 5 and 6, and of course also in Creo 7. And these enhancements are extending the capabilities, so it's easier to, let's say, define loads and constraints with the help of user-defined coordinate systems. So you can select them easily. And by the way, you can also, let's say, specify a direction by selecting an edge, an axis, or a plane, and then automatically all the components will be taken for an easy definition of your loadings. You have better graphical feedback of the selected objects. Even the IDs are available, and you can toggle, let's say, these simulation objects here. The Creo Simulation Live Legend is very easy now to handle, so we have quite a lot of new functionality in it. Maybe if you want to change here the maximum value, you can type in here the value, or you just drag here this line up and down, and let's say the legend will change, or here you can reset the legend, or you can show here different type of information, deformation, font misers, stress, and so on. So it's very intuitive and quite easy to learn how to handle this legend here. By the way, we will see new constraining capabilities. As soon as you select a cylindrical object, you can create cylindrical constraints. The same with planar surfaces or other stuff here. So that's much more easy to define here. By the way, you can also use behavior modeling extension. This is an additional module of Creo Parametric, but this is a powerful module where you can do easily some sensitivity studies, optimization, or you can test, let's say, 2000 variants by changing maybe 6 parameters. And because Creo Simulation Live is that fast, I guess, so I think this is a very, very big advantage to use these BMX capabilities of Creo Parametric with Creo Simulation Live. Okay, new loading is available, so linear acceleration is now in Creo Simulation Live. That means you can see the influence of the weight of the part, or you can see the influence when you accelerate the part, or that kind of stuff. Then you can set the focus on specific components. That means you do not have to create simplified representation or that kind of stuff. You just click on what's the scope for my simulation, and you activate that components you want to have access for the simulation. Then there are also news from Ansys. I think everybody of you knows that Creo Simulation Live is an integrated Ansys product within Creo Parametric, and they improved also their solver. In the, let's say, in the old solver, they just took the bounding box of the components and then they filled it with voxels, and then they brought in, let's say, the calculation, and that means with a fat part, very thick part, they could really bring in, or they could really analyze very good results. But as soon as the part were thin, like sheet metal part, then you needed a very, very good graphic card to fill this part, because the bounding box was filled with voxels, and therefore it was not that easy to analyze, let's say, thin parts. That changed now because they improved the old solver. It's not, let's say, filling the bounding box with voxels, it's just filling the geometry here with voxels, or let's say elements. And by the way, the new solver here uses much more power of the GPU. So in the old solver it was below 30%, and in the new solver, which comes out in about a month, more than 60% of the GPU power will be used. So we'll see here that the new solver will be available in Creo 7 in about 3 months here, and we'll see also in Creo 4 it should be available at the end of the month. By the way, for those customers which like to use floating licenses, the floating licenses are also available since about 1 or 2 months. Okay, then let's see what's coming new in Creo Simulation Live 7.0. There are new capabilities. Now we are able to analyze transient thermal behavior. That means over the time I can see heating up, cooling down effects. So quite a big story here. And by the way, Creo Parametric works now in Creo Parametric 7.0 with multi-body capabilities, and multi-body capabilities are perfect for fluid analysis. That means with different bodies here we can assign different material behavior to the bodies, and so it's quite easy to build, especially let's say fluid models there. But the multi-body is also available, let's say, in the normal product of Creo Simulation Live, because Creo Simulation Live Fluids, sometimes you will see also the name Creo Simulation Live Plus, is an additional, a new product. So that means if you have an old license of Creo Simulation Live, the fluid capabilities will not be automatically available. So this is a new product. We have here the Creo Simulation Live product, and we have the Plus product, or let's say the fluid product. And in the Plus product, we'll see here the additional fluid capabilities. Okay. What is included in the fluid capabilities? I mean, it's incredible the speed with what kind of speed you can, let's say, perform this analysis. I'm working now 25 or 30 years in simulation environment. I've never seen, let's say, such a speed for a simulation solution. And when you're a Creo Parametric user, it's very easy to handle, to set up this this kind of analysis. And of course, we'll see it's geometric enabled. That means if you have a change, you'll see within seconds what happens with that change. Was it a perfect change, or was it a bad idea? What is a good idea? So it's really designed for engineers, for developers in the design process. It's interactive. You see, let's say, online, you see the results, you see the changes immediately. And of course, you have to build your models. We will go through that. You have to build a fluid domain. This fluid domain creation is easier with, let's say, the multi-body capabilities of Creo Parametric. Of course, you can build the domain by hand, or you can build it for, let's say here, an external analysis with that kind of drag handles. We'll see that later on. You'll get a new material library for the fluids. This material library can be extended here, if you like. You'll get the possibilities, the capabilities to create external flow analysis. So you're taking here a race car, you're sending it to the wind channel, and then you see, let's say, the streamlines and that kind of stuff. quite important is also, let's say, analysis, combined analysis of flow and thermal capabilities. You'll see that this is quite easy to handle, or very easy to handle within Creo Simulation Live. And the display of the results, it's incredible. You can see the behavior with the help of streamlines, of particles. You can make some cutting planes. You can change the cutting planes. You can have influence on the streamlines, on the particles. You can define some probes and all that kind of stuff. So it's very intuitive and very, very quick, easy to handle. But let's try that out in a live demonstration. So we'll still have 40 minutes to go, and within, let's say, these 40 minutes, I try to solve several models. We'll start with a structural model and thermal analysis of a motor block. Then we'll see here the fluid behavior of water with a valve. Then we are doing a wind channel analysis of a race car. And in the end, we have an electronic enclosure, and we'll see the combination of thermal and fluid behavior. So we want to cool down this electronic component with the help of a airflow. Okay, let's start with the capabilities which are available in Creo 4, 5, and 6 with, let's say, structure, thermal, and modal analysis. Therefore, I'm changing here to Creo Parametric 7.0. Unfortunately, I was too stupid. No, the new license for the flow analysis is not available right now, and therefore I have to use the sneak peek edition of Creo Simulation Live of Creo Parametric, and let's say this is a little bit, or might be a little bit buggy, but we'll see, no problem. So we're going here for live simulation, and in this live simulation environment, by default, always CSL likes to create structural analysis, and I can just start with defining the structural analysis. Here already some material is defined. We'll see here Young's modulus and that kind of stuff, Poisson ratio and so on. And now I'm going just in and I say, okay, here on the lower area I want to create here a constraint, a fixed constraint. Okay, this is done, and maybe on that surface here I'd like to create a force. Okay, here this new capability, I can select the direction by selecting maybe an edge, and now you'll see, okay, you're getting the direction itself, the components here. I can switch here to direction components, and I want to create maybe a load in y direction of 5555 newtons. In this direction I don't want to have a load here. So we'll see, okay, set, oh, I wanted to take set direction. Sorry for that, this is live demonstration. Okay, and now this guy is there. I just can click on calculate button, and within 3 seconds I can see the results. Here we can see the stress results. Here the behavior of the legend. I just pull down here the legend and you see, okay, in the main window behavior is changing. I can, let's say, reset the legend. I can show maximum and minimum here. There is a maximum and there is minimum location. I can switch maybe to the deformation behavior. I can see the deformation with the help of an animation. Okay, you can speed up the animation, scale it. You can switch to true deformation, doesn't make sense, and if you take it off, you see just, let's say, the geometry itself. So that means very, very easy handling of analysis, and if I compare maybe the results, the deformation results are perfect. The stress results maybe in the small corners, in the small radius, they are not perfect, but it gives me a very good overall stress behavior feedback. And with the new solver, we'll see much, much better stress results. Okay, here I'd like to do now an additional analysis here. Therefore, I'm adding a new analysis. I want to create a modal analysis. Okay, and I just hit run. Now Creo Simulation Live is calculating a free mode. Maybe we can see it better if we animate it. Okay, this is the free mode, first mode at about 550 Hertz. Of course, you can see additional modes here. Going back here for the first mode. And when I'm just bringing in here maybe a fixed constraint on maybe that surface here. Okay, then you see right now, 3 seconds later, I see right now the mode number 1 with the fixed constraint. So it's very, very quick. Of course, here you can ask for more quality by moving the slider a little bit more to the right. Come on, let's move it here a little bit. And then you'll see the results. Okay, closing that one. And where are the results right now? Here are the results, yes. So it took a little bit longer. As next thing, I'd like to create a thermal analysis. Okay, thermal analysis by default is defined a convection constraint here with a convection coefficient and ambient temperature on all surfaces, and I'm just going maybe for that cylinder, and I'm creating here a heat load of let's do 2 kilowatts, and I run the analysis. It takes me another 5 seconds to see the temperature behavior. Okay, temperature behavior looks a little bit strange. One moment, maybe I have to switch down a little bit this guy here to see the temperature behavior. Let's go for flux. Now it's showing me, let's say, the temperature behavior, temperature distribution. As soon as I'm redefining here the load, now the 2 kilowatts are working on the 3 cylinders here. Okay, we'll see 1 second later. This is now the new temperature behavior. And of course, the temperature is coming down because it's that quick here. It's so easy to test. Okay, if I have 2 kilowatts and 4 cylinders, we'll see, okay, temperature coming down to 230 degrees. So that means right now, as soon within the first 10 minutes, we were analyzing this motor block, and we did around, I would say, 5 or 6 variants out of that one. If I would do that analysis, let's say, within the older mechanic or Creo Simulate products, it would take me, let's say, just for meshing, maybe half an hour. Maybe I have to, let's say, repair the geometry for the meshing. Of course, there I'm getting a very, very good stress result, but it takes me a long time. And if I'm, let's say, just a designer who likes to see the influence of some changes, then I would say Creo Simulation Live is the perfect solution for him. Okay, let's go now for next topic here. We saw the analysis of this motor block. By the way, there are some questions here. Which GPU are you using? I'm using right now a graphic card with a 6 gigabyte GPU. Yesterday I was surprised because I was installing Creo 7 on my old computer, and there with a 4 years old graphic card, Quadro M1000M or something like that, I was also able to analyze all this stuff here. Really the need of having a very, very good graphic and expensive graphic card is not here anymore because Ansys also changed, let's say, the solver and now much more graphics card. The most of them, of course, are NVIDIA are supported right now. So let's do now a fluid study of this water valve here. Within that valve we have a mechanism, and I will change later on that mechanism. And so the CSL fluids, just to repeat, is only available in Creo 7.0. This is not available in Creo 4, 5 or 6. Let's have a look at it because it's amazing, great, incredible. Okay, then I'm just quitting the motor block here. I'm changing my working directory to the valve mechanism, and I'm opening here this valve mechanism here. Okay, this is that guy here. Here I created my fluid body by hand, and we'll see, okay, when I'm hiding that component within my fluid body, there is that mechanism, and of course, because I'm a simulation guy, I like mechanism. I created here a mechanism, and I can open and close the valve here by dragging it. But right now, let's say my fluid body is full, so the influence of the valve will not be taken into account at the beginning. But let's go for live simulation, and let's create here a fluid simulation study. Okay, just to remember here, we have 2 o'clock. And let's say with a normal fluid simulation study, it would take me the whole afternoon to see the first results, but not with Creo Simulation Live. I'm creating my fluid component. I just select it because I created it before. And I'm going for my fluid body, and I'm defining here some inlet flow velocity. I'm taking here meters per second, and I want to have an inlet of fluid velocity of 5 meters in that direction. And from top here, I want to have 8 meters per second. That means I have to type in -8. Okay, direction is okay. And here on the outlet area, I'm defining an outlet pressure of 0. Let's do here maybe megapascals. Okay. That's all I have to do, and I just can start here the simulation. No, I can't start it because Simulation Live is supporting me and tells me, okay, there is no valid material. Okay, I forgot to define the material for my fluid body. Therefore, I'm just editing the materials, and I can see here my new material library, and I'm bringing in water for my fluid body. And now I'm trying to analyze my part, and within 2 seconds, I can see right now the flow of my component. I'm hiding my simulation object, I'm bringing in a cut plane, and I want to see the particles here. zooming in a little bit, and I'm going to change the particle size. Here maybe the size of that particles. Yes, now I can see it a little bit better. And I want to show here the streamlines. Yes, I can see the streamlines. I can also switch to the streamline options. I want to see more streamlines. And maybe in that area here, I'd like to change the area for the streamlines. Just hold down the switch, the shift button, not the switch button. Okay, and I can see all over my diameter all the streamlines here, the behavior. Okay. Here, by typing on that guy, I can also, starting with the streamlines here or here. Okay, I want to start here. And I'd like to change now, or I'd like to take into account my valve here. You see, nothing happens if I'm changing here the valve. And right now the valve has, let's say, that direction here. Okay, therefore I want to include, or I want to cut out the valve of my fluid body. Therefore, pressing here the right mouse button, and I want to remove here that guy. That means with the red crosshatch here, here by activating the remove geometry, we'll see here the influence on that one. And we'll see, okay, this is the influence on the streamlines, and of course the velocity here on that side here is increasing. It was 9 meters per second, now it's 14,000 millimeters per second. Okay, and now I couldn't believe it when I saw it the first time. You just drag now your mechanism. Okay, and now you see the new behavior of that component. Of course, the velocity is changing dramatically to about 55 meters per second. And of course, here in that area, you're getting a total different streamlines behavior of that guy. I'm opening the valve again. And we'll see, okay, we have now much, much better results. Here you also have capabilities to create some simulation probes. I'm going for that guy here, and I want to see, let's say, the velocity of that guy. If I change here to a time averaged display, we'll see, let's say, a more smooth behavior of the streamlines and that kind of stuff. We can open here the graph capabilities, and we see the graph over the time. And of course we can save that guy here, this probe, or maybe I call it a measure. Okay, and it will be saved in my analysis. And by the way, there are no additional files which are created by Creo Simulation Live, so I will not see any let's say result directory in my working directory. That means Windchill has no problem at all to take care of your models here. This is really very, very cool. You can create here a simulation report. Okay, and all that kind of stuff. So that was the first fluid analysis of that component. With the help of particle and streamlines, we saw the behavior of this valve mechanism. And it took us about, I would guess, 5 or 6 or 10 minutes. This is nothing, and the handling is very, very easy for a design engineer. Of course, this tool is not designed for a PhD guy who likes to see maybe the influence of the roughness of a specific wall. This tool is really for designers, and the designers can decide with the help of this simulation tool in which direction they want to go. Okay, let's do the next component. I'm shutting down my Creo Parametric guy because I know when I'm opening that new simulation it will crash. I don't know why, but I did that, so I'm starting again here, the English version. Okay, and as the next thing I want to analyze this race car. Formula One is not working anymore, but Formula One on Creo Simulation Live is no problem at all. Therefore, I'm changing my working directory again, and I'm opening here a simplified race car. Okay, here we should see that race car. Doesn't look that bad for the first simulation, and we want to do in CSL, Creo Simulation Live, we want to do an additional fluid analysis. Therefore, I'm adding a new fluid simulation study, and in that case I want to create a enclosure volume. That means Simulation Live is creating a bounding box, and I can change that bounding box. Maybe here in front I want to have 2 meters. To the side I'd like to have 1 meter. This is 1. To that direction I want to have also 1. Okay, to the top I want to have 1. And here I want to have 4 meters. Okay, this is now my fluid. And for that fluid I can set some boundary conditions. So say this is a, let's say, a slip symmetry. It's like a perfect mirror here on the bottom, and here on top I'd like to have velocity, flow velocity of around 200 k's in x direction. So I'm dividing the 200 kilometers per hour by 3.6. Okay, now it works, and I'm getting a flow of 55 blah 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 dot 55. Come on, boundary condition here, 55.5 meters per second. Here on the back I'm defining an outlet pressure of 0. Okay, and let's say the setup of the model is done. No, it's not done. I have to say the material of my fluid domain is air. Okay, and now I'm running the analysis. Okay, we see right now the velocity on the cutting surface. Here, if I'm going here for the fluid objects, I guess here by double clicking that one, I can move this cutting surface. I can rotate it. Okay, I move it back. Oh, don't want to rotate, move it back, maybe here. Oh, this is okay for me. And I want to see right now the particles. The bubbles are too big, so I'm editing the bubbles from size. Maybe something like that here. Okay, and I want to see also the streamlines. Size of streamlines, make it a little bit smaller, the width. Okay, doesn't look that bad. And here the fluid objects are selected with the filter, therefore I just can double click that guy here and influence it. Holding down shift button it will be scaled. Holding down control button, I have here the ellipse behavior, and holding down nothing, it's also the ellipse behavior. With the right mouse button I can duplicate it, add streamlines, and with the drag button I'm dragging it down here. I'm dragging that maybe back. Oh, this was too much. maybe on that side here. I'm selecting that guy again, dragging it here back, and I'm moving it maybe in the blue direction. Okay, to see that behavior. So very, very easy handling for the post processing. Really, it's incredible. It's very, very fast, and really here my calculator, my laptop, it's a Lenovo P52. This is 1-year-old laptop with a NVIDIA graphic card with 6 GB of RAM. GPU RAM. Okay. So now we saw Formula One, now race car, wind channel. Let's do maybe the last component I prepared here. We want to analyze an electronic enclosure. Therefore, I'm going back for Creo Parametric. Okay. I'm selecting the next working directory. And I'm opening that guy here. Okay, we have an enclosure here. And I'm just going to hide that enclosure. Let's go maybe first. Oh, I'm hiding it here. Hiding it here. Inside here we have the, let's say, the fluid domain, and we're going for the analysis here of live simulation. I already prepared the fluid domain, the fluid boundary condition, and so on. That means, okay, here on that side I'm blowing in some air with 3 meters per second. On the back there, on the green surfaces, this is the outlet. Okay, and we have an initial temperature on all components of, I guess it's 20 degrees, yes. And we have a convection condition on the outside of our enclosure with that convection coefficient and ambient temperature. Okay, and here we have heat of about 5 watts on that 2 cylinders there. Okay, and with that information I'm hiding the simulation objects. Quite easy to hide, unhide it. I'm starting now the analysis. Okay, I can see right now the velocity on the outside surfaces here. I'm changing now my option here to inverse surfaces. That means right now I can see into my component and I can see right now the velocity. I'm changing to temperature. Of course I can see, okay, the temperature right now it's in Kelvin. I'm changing to degrees. Of the second cylinder is around 35 degrees. It's still increasing because this is a transient analysis. And of course here I can, let's say, change from temperature to velocity, and I'm bringing in again my bubbles, my particles. I'm changing the particles, the size of them, maybe here, and I'm bringing in my streamlines, and again I'm changing the fluid objects by holding down the shift button. I want to see more of the streamlines. Okay, and I'm watching here from top. And I can see here, yes, my cooling body doesn't work really perfect because there is nearly no flow here through the ribs. Therefore, as an engineer, I think, oh, might be better if I'm changing here that extrusion of that body, and in the end I want to have maybe here a body with maybe a shape of that one here. Okay, and I'd like to move the inlet here a little bit to the right. This is just a stupid idea. of a design engineer, but because it's that easy to test that ideas, I will do it live with Creo Simulation Live. Therefore, I'm going for my fluid body, not to my fluid body, to the body cooler here. And we see we have here two suppressed features. And by resuming those two features, we'll see that our shape here of that guy is changing. We have now this shape here, and we see, okay, the streamlines, the flow was changing, and of course the temperatures will also change. And now I'd like to move the inlet here. This construction was built in a little bit a strange way. I have to change the fluid body to change the inlet, so I'm going here for that extrude. I'm just changing the dimension here from that 0.5 meters to that 0.75 meters. I have to hit here regenerate in order to see, let's say, the changed dimension. And of course here I'm going back for my fluid objects. This guy here should be moved a little bit to that direction in order to see the behavior. And now we can see some of the streamlines going here through the ribs, and I hope that my cooling behavior will be better than before. Of course, I could think now about some additional sheet metal parts where I'm going to assemble here to let's say bring the flow in a specific direction. All that kind of stuff can be easily made, and as a design engineer in many cases I just want to see the influence of my changes, and that's really very easy to handle with Creo Simulation Live, because it's incredible quick, it's incredibly easy to handle, because that is a Creo Parametric. I'm using Creo Parametric every day, so I know where the buttons are. And I think also with this cool interface here, which was designed by PTC and perfect technology of Ansys, we have really a very efficient tool for design engineers. Yes, so that's nearly all. So again here, let's have a look at the time. Here is the time, sorry, 20 minutes past 2. So we started with live demonstration about 1:45, so it took us 35 minutes to analyze all that stuff here. Going back here for my PowerPoint, so we analyzed first motor block with structural, modal and thermal analysis. Then we had a look at the valve with the mechanism. Then we were defining, let's say, or we were analyzing the wind channel behavior of our race car. And in the last example, we started to analyze the electronic enclosure, and we started to optimize this electronic enclosure. And we saw it's, I can say it again, it's incredibly fast on a normal computer. That brings me to the end of the live presentation. So here's some internal logistics. We as a GIA, during a COVID crisis in May, we are doing some workshops. They also can be in English with mechanism, simulation elite, freestyle and flexible modeling. And now we have 5 minutes time for your questions, so please use the question panel. Question is how best to create the fluid body. Can this be done within a single or multi part? It's up to you how you like to do it. Sometimes it's quite easy to do with the multi-body technology. So I'm going maybe here back to Creo Parametric. I hope this works. I'm just creating a new component. I'm taking, let's say, a stupid cylinder. Okay. This should be my component. I'm going here for that guy from my planes. I'll say here, okay, I want to create an additional extrusion. Maybe on that side. Okay. Okay, I don't want to remove material. No, I don't want to remove. I want to add material. Come on. Add material here. Okay, this should be my pipe system. Therefore, I'm creating here a shell. Okay, here, shell. And now with that guy, I can go for Creo Simulation. I'm creating here a fluid analysis, and here there is also an option to create an internal volume. That can be easily done. I say, okay, internal volume, and by just selecting the outer surfaces here. Okay, the internal volume will be created. This is multi-body technology. So I have now this internal body, maybe here as a, yeah, you can see here the internal body. This is the main body, but for let's say the internal volume, I was taking that guy here. And of course, just show you very quick, here I'm bringing in again magnitude, x direction, 5 meters. Come on, 5 meters per second, maybe here inset minus 9.8 or something like that meters per second. Okay, let's do here an outlet pressure again. Okay, and let's assign here material to my fluid domain. Let's take water again, and now run it. And we see now the behavior here. So that can be easily done also with the multi-body technology. Okay. Here we see, okay, I have to take the fluid object, and if I want to see the cut here, I have to change the cut maybe to 90 degrees. Now it's nearly perfect. Okay, then other questions. Can you please say when flow analysis will be available? Flow analysis is available since 2 days, but you must have a Creo Parametric 7.0 installation, and you must update your license to Creo 7, and of course you must have at least a testing license of Creo 7.0, or if you are a reseller, you must update your license, and they should be available at the end of this week. Then we still have some minutes. I see you add an inlet velocity in meters per second. What are other units available? Kilometer per hour? Yes, there are different units available, and of course it depends on let's say, what's the main unit system of your component, then it says, okay, we can use that kind of stuff. Right now we have feet per second, we have inch per second, we have meters per second. Yes, unfortunately kilometers per hour is not available, or miles per hour, but I guess this would be an easy thing to add here, but these are right now the units which are available right now. Okay, then let's have another look at other question. One moment. Which GPU are you using and how much memory? I think I can show you that one. Here, I think it's under, no, wait, it's under System Anzeige, which means graphics, and I think it's this guy here. And you can see here I'm using right now this NVIDIA. This has 6 GB of GPU. This guy here. So this is, let's say, the normal or a better NVIDIA card, which is our Müller-Martini group model using for their 100 designers. So it's, let's say, a better standard card. It's 1 year old. Okay, and from RAM side on my Lenovo, I have 32 gigabyte of RAMs, but this is not that important. And as I told you before, on my old laptop, P50, with an old graphic card, it also works, and the performance is good. It's not that perfect as here, but it's good. But I think quite soon we'll have a new list of the, let's say, supported graphics card for Creo Simulation Live. But with an old graphic card, it will not work. Yeah, so I think there are still some questions here, but oh yes, we have nearly 2:30. I would say if I did not answer your question, please feel free to ask your question by email. That brings me to the end of my webinar here. It was a pleasure for me to show you the new capabilities of Creo Simulation Live for Creo 4, 5 and 6, and the new product called Creo Simulation Live Fluids or Plus, which is available since 2 days in Creo Parametric 7.0. So thanks a lot for your time. It was a pleasure for me to present, and stay safe and sound, stay at home, and I hope we'll see us live somewhere else. See you soon. Bye, arrivederci, a bientôt, auf Wiedersehen, au revoir.